Ladies and gentlemen, I want to talk to you about code sharing between web and mobile applications, and and basically we'll be talking about how to do it in Spectrum with using Angular and using NativeScript. So yeah, I'm Sebastian Witalec. I'm a senior developer advocate working for Progress. So we basically we created NativeScript. Therefore, I think like I have a bit of expertise on the topic itself, and I was pretty much involved from day one in the creation of NativeScript. Like I'm not in the engineering core team. I work in DevRel, but I was involved in NativeScript from the very early days. So if any of you is on Twitter, you can follow me at Sebawita. That's basically the first 4 letters of my first name and surname, so it's easy to remember. So first things first, I'm not sure if everybody knows what NativeScript, like hands up, who knows what's NativeScript? Oh, there's actually quite a few of you. That's good. Great. But for the rest of you, it's basically an open source framework that allows you to use your existing like web development skills. So if you know JavaScript, if you know Angular, Vue, if you know how to use like CSS and pretty much like all this stuff, you could use those skills to build mobile applications. The thing is that the applications that you build with NativeScript, they give you access to the native APIs, and the UI of the application is 100% native. So there is no web views involved whatsoever. The applications that you're building, they not only just look and feel, they actually are native underneath, which is pretty cool. And then basically you can target both iOS and Android. So the goal for today or for this talk really is how can we have a single project that allows us to build Android, iOS, and web applications. So everything just like from a single project, and then targeting 3 separate formats. So in short, it's basically an idea of one project, 2 docs kind of thing. They're pretty cute. So my recipe for that is pretty much just like the combination of NativeScript and Angular, right? So NativeScript gives you access to building iOS and Android applications, while Angular gives you ability to build for the web, but also it provides you the architecture required for the code sharing, right? So pretty much like all that you will see from this presentation is based on Angular concepts and how we used the way it was designed to achieve this goal. So some of the core concepts that kind of, at least for me, early days made me aware that there was always a possibility to use Angular for this specific task. So if you wanted to, for example, build a very simple application where you'd have a player component, which would have, for example, a name and a Twitter attribute, right? So Sebastian and Sebawita. And then we would also have a method called say hello to, and then you could pass in name, and then you would, let's say, do a pop-up with an alert saying like hi and whatever name you pass, right? So that's our component. And then we could have a template, right? So a simple template where we can just use double handlebars to display the name and the Twitter attribute. And also we have a button where on click event, we can just call our say hello to. And then in this case, if you click on that button, it would just say hi web, right? Nice and simple. The thing is that I can actually use the same component, but I could have a NativeScript specific template, which would use just slightly different components. So in this case, we wouldn't have a div because there's no such thing as div on iOS or Android, right? This is a web thing. So in our case, we would use our stack layout. We would have a couple of labels where we would display again the name and the Twitter handle, but also we can add a button, and then that calls the say hello to, and let's say passes the mobile. One of some of the differences that you probably notice here as well is in the web template we call click because you click on in the web browser. On the mobile you tap, so you basically bind to the tap event. But the whole idea is that like we just have a single component and we just have to implement twice the UI for the 2 of them. Because let's face it, most of the time how the web application, how the mobile applications look like, they should be different, right? In many cases with web applications, you'll be targeting a screen that is like 20-inch big, right? While in case of a mobile phone, it will be something that is, 4 or 5 inches max. That's kind of the idea. Another thing that's really, really helpful with the whole crusade for building code sharing applications is dependency injection, which comes really, really handy. So if we look at an example of, I want to make an HTTP call from my application, the thing is that the way it is implemented on web and mobile, they're very, very different, right? So in a web application, you will make an AJAX call. In terms of a mobile app, you cannot make an AJAX call from an iOS SDK or from Android, right? So the solution to this is pretty straightforward. So in a web application, you'd be using HttpClient module, and you would add it to your ng module, right? And then what we can do in NativeScript is like we have an equivalent of the HttpClient module, which we implemented as NativeScript HttpClient module, which provides you with the same services with the same interfaces underneath. But then in your NativeScript ng module, we just inject the NativeScript version of it. And then later on, when you're actually building your service using the HTTP client, right? What you do is just use the dependency injection to pass in HTTP client. And then at this moment, if you build this project for web, you're going to use the web version of it. If you're building this project for mobile, this service is going to use NativeScript's version of the HTTP client. But to you as a developer, it doesn't really matter because this is all handled by dependency injection for you. And then so that implementing the actual service where you want to, let's say, implement get data, you could very easily just do this.http.get, pass in the URL, and you're good to go. But you don't have to write this service twice. It's just one service that will work on your iOS application, your Android application, your web application, which is really, really handy. So some of the things that were important is like, okay, so we need some sort of project structure to achieve code sharing, right? Because like in theory, all of this should be possible, but how do we get there? So the way I envisaged it, and this is one of like two different approaches that I know of, but one of them is basically you use like a monorepo approach. So you have one big project where you have you know all your services, when you have your navigation configuration, when you have your directives, pipes, you could have like a common style variables if you're using Sass. But then you would have two separate style sheets. Like you would have one web-specific style sheet and one NativeScript-specific style sheet. But they would inherit from like the same basis. Then we would keep all our components within the same project. And then the thing is that most likely you'd be reusing the TypeScript class of the component, but then you would have two separate HTML files, one for web, one for mobile. And then last but not least, you can also share a lot of the modules. So if you're using lazy loading for your modules, then the modules themselves can share the components. They can share even the navigation of inside the module, but you would probably have two separate implementation of what goes into the ng module. And this is actually really handy if, for example, if you want to use Angular material for the web, but you want to use like a NativeScript UI Pro components for NativeScript, right? So you have two separate places to import them, which is pretty cool. So once we have this kind of project, what we need next is some sort of build process that can take, for example, all the black and white ones with elements which are shared, and let's say the web specific in red, and then use the Angular CLI to build the application. All the same build process should be capable of ignoring the web specific files, but take the NativeScript specific ones and the shared files, and then give you a mobile app application as a result. That's pretty much like the idea. Another thing is, so like I mentioned here, like you would have a component that would have a shared TypeScript class, but then we would have two separate HTML files. How do we achieve this code splitting, right? That we can have two HTML files. How do we tell Angular to pick which file at which point, right? So we're looking at basically some sort of code splitting technique. And we do it basically by a naming convention. So if we, for example, take this name component, and for our web, we just have name.component.html, and then we have another file, which will be name.component.tns.html. This is basically how we say, okay, if you see .tns, that means this is going to be a mobile-specific file. And then you can apply it to anywhere. So if you want to have two versions of the same service or any TypeScript file, you can do .tns.ts. If you want to add styling, you could, for example, have name.component.tns.css for NativeScript, and the one without .tns is a web specific. So you could basically split any file you want by just using this simple naming convention, which is pretty cool. So obviously, this is like all like how I saw it like a year and a half ago. It's like in theory, like this is my starting point. This is what I want to use, and this like how I envisage the whole thing working. But obviously now you kind of thinking like, okay, I want to see it in practice. Like, how do I get my hands on it? So the cool thing is that we implemented NativeScript schematics that actually help you with building code sharing projects. So if you install using npm and add NativeScript/schematics, you can then later on, for example, create a new project using Angular CLI. So if you just call, as usual, like ng-new, and then for the collection, so you do either -c or -- collection, and you pass in the add NativeScript/schematics, then provide a project name, and then add the -- shared flag at the end. That basically use Angular CLI to scaffold a brand new code sharing project from scratch. And that works pretty well. So how does actually the whole build process work from a shared project? In a way, if you want to build a web application, it's business as usual. You just call ngserve, which will call Angular CLI, which will build a web application for you. Okay. If you want to build a mobile application, then we are using Webpack. It's kind of like in a two-step process to achieve that. So you could call basically, so TNS is our CLI for NativeScript. So if you call TNS run, and then you choose either Android or iOS, and then -- bundle, so you notify that you want to use Webpack for the build. What will happen is, first Webpack will look at the project, and you try to find all the .tns files, and then in virtual file system, you replace all the .tns, like you literally remove .tns, and then override the shared, the web-specific files. And then as a result, and then also take the shared files, and then as a result, in a virtual file system, you recreate a NativeScript project, as if the web one wasn't there. And then as a second step, it passes it into the NativeScript CLI, the regular build, and then builds the project for you. But basically, the whole idea is like you just run TNS run, either Android or iOS with -- bundle, and the code sharing project turns into either Android or iOS application. So to picture that, how this actually works exactly, I have a good video that should show it quite well. So the Tiger is a NativeScript build. The duck is basically the web-specific files. So we don't want the Tiger to get the duck, right? So we have Webpack here, right? The whole idea, and this is how it works. This is for real. This is what happens underneath in our build system. See? And this is basically how our Webpack helps us avoid, catching the web-specific file, which I think is pretty cool. So I'm gonna do a quick demo, and you can all check it out as well later on. So you can check that specific GitHub repo. And what I did is I went through. You all know the Tour of Heroes tutorial on Angular IO, right? So I went through the tutorial, built that project, and then I went through a process of migrating this project into a code sharing project, right? So what I'll be showing you now is basically an already migrated project into our code sharing structure. Let's start. So this is the project. Can you all see the work? All right. So from this project, what I can actually do is call ngserve-o, and then at the same time I can run tns run iOS -- bundle. So that will go and build the project for me in the simulator. And then while this is happening in the background, I want to show you some of the bits. So the project, initially it could kind of like come up as a little bit scary because there's more files than your typical web-only project, right? Because we'll have some of those additional .tns files. But it's actually not that scary. It's basically we just have separate files for whenever we need the separation for, okay, this is web-specific or this is mobile-specific. So one of the first places where you want to split those things is inside the like the actual app module or your entry module, right? So in this case, for example, like I was showing you before, we would be using an HTTP client. So in the web specific one, we use HTTP client module. In the NativeScript specific version, we're actually using the NativeScript HTTP client module. But if you look at it, is everything else is actually pretty much the same. So we use the app routing module. We use the HTTP client in-memory web API, which came with the tutorial itself, and using also the in-memory data service. And then this is pretty much the same in our web version. One of the other things in here that we have is the hero service itself that allows you to, for example, get a specific hero or search for heroes or get like the whole list of all the heroes, right? And the funny thing is that when I was migrating this project, I actually didn't touch this file, right? Like this file was already there. It worked for the web, so I trusted the same service using HTTP client underneath is going to work for me, and it did. And then if we look just at the heroes component itself, so in here you can see I'm importing the hero service, which is basically how this service, this component was here out of the box. And we have those functions for like get heroes, add hero that we exposing and then delete. So far, like none of those things I changed. And then when we have the heroes component.html, we have just like a quick input where you can enter a hero name with a button that just calls add. And then we're using an ng4 to display all the heroes, right? So in terms of our web project, this is basically our heroes page, right? I can add Sebastian here, and then I'll be added at the bottom. The messages get updated, or I can remove a couple of those, right? So the next one is basically we have the web version of the template, but we also have the NativeScript equivalent of that. So in this case, I'm just using a slightly different layout. So I'm using a text field to capture the hero name. And I'm also using the same technique where I'm just doing hash hero name. And then in my button, when I click tab, I'm just passing the hero name.text. It's kind of like the same thing. And then instead of using actually an ng4, because this is a mobile application, I'm using a list view. So in this case, I'm just pointing it to the heroes collection. And then for every record, I'm just creating like a label with the hero's ID, name, and then this is the hash code for just the delete button, or delete icon. And then whenever you click on it, I can delete the record. Some of the things that I have here is like if you tap on any of the items, I am using the NS router link, which navigates to the details page. So if I show you that, how this looks in action, this is basically our mobile application with pretty much the same page. So how about I put them side by side? That's like so that you kind of get an idea. So in here, I can also do, what's that? Double L, right? And then like here appears at the bottom, I can remove tornado, dynamo, I can navigate to the details, just like I was here. So it's pretty cool. Like the real difference inside this specific component is basically just these two files. Like I just implemented the templates twice, and then that's kind of the thing. Another really cool thing is where you could say like, okay, so you have all these different components within NativeScript that you don't have, like divs and labels, h1s, etc. Right? How about the components I create myself? So in this case, in here, there's a component called hero search, right? So the hero search will have a selector app hero search. And then this is basically one where if I go to a dashboard, and then I can put like two, then that basically searches for all the heroes and then gives you an option to choose like either one or the other, right? So in this case, the hero search component again uses the hero service that performs the search underneath, and then we have this like HTML template that defines what happens in the web. So what I did here is I literally just added the equivalent for NativeScript. So I also added a template, say, okay, so just have a little text field where you can enter the search text. And then whenever you get new results, I'm using an async pipe, and I'm going to display just a list view with a single label and the hero's ID, right? And the cool thing is that then, like I showed you here, hero search component, I have my app hero search. So in the dashboard itself, first, you see, like we just adding it in a web template by just adding app hero search. And also in a NativeScript template, I'm only just adding app hero search. So the components that you create locally, like within your project, you can actually share them. So technically, you could eventually end up, if you create a higher abstraction with components that even have identical HTML files. Like that's also possible. That's perfectly fine. So in this case, the hero search, if I go to the dashboard, I can start searching, and then Kirill appears, or I could go to, and we have Bombasto, etc., etc. And pretty much like that's the whole idea. Some of the differences that, and this is the thing I'll always be saying, like, just because we can do code sharing, that doesn't mean that your project should always also be identical. Because for example, in here, you see like we have those log messages appearing here. Why? Because we have a ton of screen and we can't, right? But you would not want to have those messages appearing at the bottom of your mobile application, because basically the space on the mobile app is sacred, right? Like you cannot be wasting it. So in this case, I just put it into a separate component. So I created like a messages component, which is NativeScript only or mobile only. And then in this case, we still have the same functionality that we can see all the same messages, and we can also clear them. But then in this case, that would be the difference for my application, where most of the functionality will be overlapping, but there will be, let's say, one component that is actually different or mobile only. And that's pretty much the whole idea. So like I mentioned before, if you want to check it out, you could go to this repo, and you could just clone it and then start playing. One thing that I didn't demo just yet, we have this command which we added recently. So normally when you build mobile applications, you have to have Xcode and Android SDK installed locally on your machine, because basically the build happens on your machine. But we have like another way of building application, which is TNS preview. And that's pretty cool. So what happens, and I'm not going to demo the full process, but the whole idea is that when you run TNS preview -- bundle, and that's not just for code sharing, that's basically for any NativeScript project, you get a QR code. And what do you do with QR code? There's an application called NativeScript Playground and NativeScript Preview. So there are two applications. So if you open NativeScript Playground and scan this QR code, basically the project will connect with your phone, perform the Webpack build, and then push it into your phone directly. And then you open inside the NativeScript preview application. The cool thing is that you don't need to have Android SDK or Xcode installed on your machine, because we are not rebuilding the native application. We will just be rebuilding the JavaScript part of it and push it into it, which basically means that I could grab anybody's laptop. I could literally grab this laptop and run this project within 3 minutes if there is NPM on it. And also, if you're working on a Windows machine, but you still want to build iOS applications, you can use Preview to play with it. This is not, you cannot use a Preview to build the end application. Eventually, when you're ready to publish the app, you still have to get a Mac at some point. But at least to get yourself started, you can actually use the Preview to move on and work on the project. So that's pretty much the idea. So that's what I want to show you with this project. Let's keep going. So first thing I showed you was like this whole ideal scenario where you come to me and you say, I want to build a new application now, right? This is like, for me, this is perfect because I can give you a clean project that you can start from scratch. What's gonna probably happen is you're gonna come to me and you say, hey, I already have this web application that I spent 6 months building and I want to add mobile to it, right? And this is basically 80% of the cases when I talk to people that's actually happening. So what I did, and we basically created a whole migration story using the schematics. So you all know NGArt. So basically, this is the root kind of that we going through. So imagine you already had an existing project that used Angular CLI to create. Right? So 6 months ago, you run ng-new my app, and you have this web project. Let's say you used ng upgrade to keep your project up to date, because you should be at least on Angular 6 in order for it to work. And the next thing that you can do is actually call ng-add NativeScript/schematics. And this will go and like kind of work out in few steps. The first step, it goes in and looks at your project and analyzes it. So it looks like what's your entry module, what is your entry component, and then based on that, it converts your project from web structure to a code sharing structure. It doesn't convert all your components and all your modules, but changes just the structure of the project so that it's code sharing ready. Okay, and then after that, you could call ng-serve, which will create the same web project that you had before, but also you'll be able to run TNS run iOS or Android -- bundle, and this will build like a really simple mobile application with just like hello world component. Okay, but the project is ready to be migrated step by step. Okay, there's also something that it's under development, so that's not completed just yet. But if you have an existing NativeScript project, we see that you could call an ng generator add web, and then this should do the reverse, where it takes your NativeScript project and converts it into code sharing one. And then again, you can call ng-serve or TNS run iOS or Android -- Okay, so we had the web-only project. We converted in a code sharing structure, and then after that, we have to go through more steps. So the next step is going and converting your individual components into code sharing components. Okay, so if you had, for example, a home component, what you could do is basically call ng-generate migrate component, and then you pass in the component's name. And what this will do is basically take your home component and add the .tns.html. And if you were using Sass or CSS, you also add .tns.sass. Also, if you then go to the .tns.html, it's not going to do all the magic of translating your divs and paragraphs into NativeScript components. But what it will do is like it will leave the copy of what was in the web in a commented out, and it will all be commented out so that you'll be able to look at it, and then you could just go one by one and actually recreate the mobile version of the template. So that's how you can migrate components. If you have like existing modules that has like a bunch of components inside, rather than migrating and calling migrate component for each component there, you could actually just, like in this case, you have like a menu module. You could call ng-generate migrate module. And it works pretty much the same way. So this schematic will call first for each component that you have inside the module. You actually call ng-migrate component for each of them. So first you convert all the existing components. And then after that, you keep the existing like the roots and the common file, but then it will split the ng module files for you and already provide you some of the NativeScript specific imports and declarations inside. So that's quite handy. So like for me, this basically deserves a proper high five and a fist bump. Kind of the idea. So just to recap, migration commands that we're looking at, we have ng-add for add NativeScript/schematics, so that converts it to a code sharing structure. And then you use migrate component and migrate module to migrate each individual component in the module. I'm actually working on a tutorial like the one of how I migrated the Tour of Heroes to a code sharing project. I'm planning to publish it early in January. If you follow me on Twitter, I'll be announcing it, and you'll be able to actually do it yourself as well. I have most of it written. I just have to do the last final polishing of it. So I talked to you basically about the approach of how I envisage doing the code sharing using Angular and NativeScript through using a mono repo. But obviously, and especially that Jason's here, and like a lot of you know about NX, you'll be asking about different ways of doing it. So an alternative is created by the guys from NStudio, and they do a lot of NativeScript work as well. They created this thing called kplat, And kplat is actually based on NX from Narwhal. So this is basically a slightly different approach. But if you are familiar with NX, I would actually recommend having a look at kplat. And the way I see it is not a competition of which one is better. It's basically, it depends on the scenario in which, or a type of application that you want to work on. So especially kplat would be good if you want to have more than one mobile application, more than one web application sharing the same code. Or it also depends on how much of the application do you share. If you find yourself in a situation where you share 3 components, but 20 other components are completely different, that they don't even you don't even display them here or there, then probably you might be better off with kplat. But then if you have a lot of overlap where you have almost the same navigation and almost the same components, like I was showing you Tour of Heroes, then definitely the schematics approach is going to be better. And to make it better, you can even make a hybrid. So I already work with some people that used kplat and the NativeScript schematics together. So you can do that too. We just haven't done enough work on the research to say this is 100% safe. But I know of people that made it work. So it's just like something that is not officially supported, but I think it's definitely a doable thing. And I'm working also like directly with Nathan Walker from NStudio on kind of bringing kplat and the schematics that we have together. All right, so yeah, thank you for listening, and yeah, I hope you enjoyed it. So basically, the question was that you tried like the repo that I shared, the Tour of Heroes, and was pretty clear how to build a web application, but it wasn't very clear on how to build a mobile app. And I think that's because I didn't actually migrate the README file, which is a good point. But one of the best places to go if you want to find out more about it, and find out like how to actually do the code sharing and like the whole migration. So we have our documentation at nativescript.org. And then in this case, if you want to actually from that project, if you, for example, call TLS run iOS --bundle or Android --bundle, then that should do the trick. But that means you have to have Xcode installed or Android SDK. But yeah, if you check out this documentation, that probably gives you, will give you a lot more information. Yeah, you can probably check it out over here. And also, before anybody asks, I'm gonna tweet my slides on Twitter. So if you wanna get hold of my slides, they just went live, so you can get them from my Twitter account. Here they are. So it's actually the same slides as I used for ngPwn. Is it possible to detect whether your mobile phone is online or offline? Yeah, it's basically, so that's something that is really cool in NativeScript. Pretty much any native calls that can be done on iOS or and Android, you can call them directly from JavaScript. And we already have like a utilities library that you could actually check, like is online, is offline, or even when you're online, you could check what sort of connection you are on. So you could check whether you're on Wi-Fi, 3G, 4G, or something super slow. So you can definitely do that. It's quite simple. Do you have a way to call advanced native features from Android and iOS? So the answer is yes. So that's something very special about NativeScript. We have this special bridge that basically translates any JavaScript code that you make, and if you're in the Android or iOS application, directly to the native SDKs. So if there is a functionality that exists on Android or in X or iOS, you can actually call it directly from iOS, and there's literally no exception. So I think last year when Apple released the new augmented reality library, we had a guy that like Eddie Verbergen. I'll show you this guy. He's our like a plugin master. So Eddie, within 48 hours, he created an AR plugin based on what Apple released. So it's literally like you're watching the presentation online of how they were showing it. 48 hours later, I already had it on my phone. And that's basically because you have direct access to the native API and pretty much any functionality that's there. Yeah. So basically anything that runs Android or Xcode, you can make it to work. It's not going to work on watches or Apple TV. We don't have a direct support for it. Like we have people who actually built for Apple TV, but that's just something we don't officially support. Like if Apple decides to mess it up and change it completely for Apple TV, we won't be able to help. But we'll definitely always help for all the iPhones, iPads, and Android tablets and Android phones. All right, cool. Thanks for your time.